Hi everyone, and welcome to this beginner-friendly roll ball game tutorial. In this lesson, we'll go step by step to create a simple game. We'll cover making 3D objects, creating materials, writing scripts for ball movement, setting up a smooth camera follow, and spawning or rotating objects in the scene. The best part is that this project is really easy to follow, and even if you're new to Unity, you can have a playable game ready in under 30 minutes. So, let's get started and build our game. Create a new 3D project with any name you like and click on Create. I've already made a new project earlier, so I'll just open it. Let's start by creating the folders we'll need for our project. Audio folder for all the game sounds. Materials folder. Scripts folder. And one folder for prefabs. Now let's create the sphere and rename it to ball. I'll also reset its transform component so it's positioned exactly at the center. We'll add a rigid body component to give our ball movement, and we'll also need a collider component for it. Now let's create a plan for the ball to move on. We'll rename it to ground and reset its transform. As you can see, the ball is inside the ground, so I'll adjust its position to place it correctly just below the ball. Now, let's scale up the ground a bit. Now, let's create a few cubes and scale them up. These cubes will act as walls to prevent the player from moving outside the ground. We'll also reset the transform of the cubes. Press Ctrl+D to duplicate the previous wall and change the X position to a positive value to place the new cube exactly on the opposite side. Now, do the same steps for the other two sides of the ground. Now, for the last wall, instead of changing the X position, set the Z position to a negative value to place it correctly. Now, let's move on to creating materials to change the color of the walls. To change the color of the walls, simply drag and drop the material we created onto each wall. Let's create another cube that the player can collect. After creating the cube and changing its color, we need to assign a tag to it so that we can access it in the script. Now, assign the tag we created to the cube and drag it into the prefabs folder to turn it into a prefab. After that, we no longer need it in the scene, so we can delete it from the scene. Now, let's set up the camera so that it gives us a top-down view. Now, let's create the scripts needed for controlling the ball and camera, spawning the collectible cubes, and handling their animations. Now, let's move on to writing the player's script for controlling the ball's movement. First, to move the ball, we need to access its rigid body component. Now, in the start function, we'll get the rigid body component. Here we read the horizontal input axis and store its value in a float called x. And here we read the vertical input axis and store its value in a float named z. Here we apply a force to the rigid body using the x and z input values. This pushes the player in the direction they're trying to move, allowing physics-based movement in the scene. Now, assign the script we wrote to the ball game object. As you can see, there's an error caused by incorrectly spelling horizontal. We can easily fix it by correcting the name. Now, let's run the game again. As you can see, the error is fixed, and we can move the ball in different directions using the keys. As you can see, the ball is moving very slowly. To increase the ball's speed, we declare a public float variable called speed and set it to 10. This controls how fast the player will move. To apply speed, we need to multiply the x and z values by the speed variable. This will make the ball move at the desired speed. If you enjoyed our video, don't forget to like and subscribe. We post new videos every week with bigger projects and tutorials. Now, let's move on to creating the script for the camera to follow the ball. Here we declare a public GameObject variable named player. This lets us assign the player object in the Unity inspector. Here we declare a private vector3 variable called distance. It will be used to store the distance between objects in 3D space. In the update method, we keep this object at a fixed distance from the player by adding the stored distance to the player's current position. In the start method, we calculate the distance between this object and the player that we stored in the distance variable by subtracting the player's position from our own. Now, assign the camera movement script to the main camera and set the ball game object as the player reference. Run the game again, and as you can see, the camera now follows the ball in all directions just as we wanted. Now, let's move on to writing the script for spawning the prefab we created earlier. Here we declare a public GameObject variable called prefab. This allows us to assign a prefab in the Unity inspector for instantiation later. This is the spawnObject method. Inside it, We use Unity's instantiate function to create a new instance of the prefab we assigned in the inspector. Create a new vector3 and use random range to generate specific coordinates for spawning the prefab. To find the coordinates, go to the inspector and drag the prefab into the scene. Then, using the transform component, we can determine the positions for random spawning. To X position a random location within -9 to 9. The Y coordinate is set to 0 so it stays on the ground. Add another random range for the Z coordinate. Set the Z coordinate to the same values as before. Finally, we use quaternion.identity to make sure the object has no rotation when it spawns. This allows us to assign a collectible script or object in the Unity inspector for later use. In the start method, we call the spawnObject function from the assigned collectible. This spawns the collectible object as soon as the game starts. Now, go to the collectible prefab and assign the script to it. Then assign the prefab to the script. Now, select the ball game object and assign the collectible prefab, which has the collect script attached to it. Run the game, and as you can see, each time the game starts, our prefab spawns at a different random position. In the update method, we create two random integers, random_x and random_z, each ranging from 0 to 3. These values are then used to rotate the object every frame by calling transform, rotate, with a new vector 3. The rotation occurs along the x and z axis, while the y-axis stays fixed at 0. This makes the object rotate in a random and dynamic way over time, giving it a lively appearance in the scene. When you run the game, you'll see that the collectible looks much nicer with a simple rotation animation. Now, let's move on to writing the script so that when the ball collides with a collectible, a sound plays and a new collectible is spawned. Here we declare a private audio source variable called source to play sounds, and a public audio clip variable named clip, which allows us to assign an audio file in the inspector. Here we assign the audio source component attached to this GameObject to the source variable using getComponent. This allows us to play audio through this object. This is the onTriggerEnter method, which is called whenever another collider enters this object's trigger. Inside, we check if the collider's tag is collect. If it is, we play the assigned audio clip once using source. Then we deactivate the collected object by setting it inactive with othered GameObject set active, false. Now, we assign the sound to the ball game object and add an audio source component. Run the game, and as you can see, everything works correctly. The only issue is that my computer's sound is off. Another problem is that after collecting one collectible, nothing else appears. Let's fix that issue next. All we need to do is run the object spawn code one more time. Just copy it and paste it inside the method. As you can see, in less than 30 minutes, we've created a simple game. To support us, you can follow us on YouTube. We're just getting started and plan to create many projects with new videos uploaded to the channel every week. I hope you enjoyed this tutorial and see you in the next one.